So welcome to this session on apcalculus. We will be discussing a few questions on apcalculus, questions 12 to 17. So let's get started. So the graph of a function and its derivative, this is the topic. You're given graph of f dash x. When does the maximum of fx occur? Now f has a maximum at x equal to c if f dash a greater than 0 for a less than c, f dash c equal to 0, or f dash a less than 0 for a greater than c, f dash c equal to 0. So we can see that at minus 2.5, f dash a is less than 0, so it doesn't hold. But at minus 0.5, f dash a is greater than 0 when it is to the left and less than 0 when it is to the right. Again, for 0.5 it does not hold. For 2.5 also it is less than 0, greater than 0 for x less than 2.5 and less than 0 for x greater than 2.5. So f has a maximum at x equal to minus 0.5 and x equal to 2.5. Now question 13 is again on graph of functions and derivatives. You are given this figure here. In which interval is the graph of fx concave up? Now if the graph of f dash x is increasing, the graph of fx is concave up. So according to the interval minus 2.5 to minus 0.5, the graph of f dash x is increasing, and if you look at 0 to 1.5, 0 to 1.5, the graph of fx is increasing. Minus 2.5 to minus 0.5, it's increasing and then decreasing. Minus 0.5 to 0.5, it's again decreasing and increasing. Minus 1.5 to 0, minus 1.5 to 0, again it is increasing and decreasing, but 0 to 1.5, it is only increasing. So it is concave up in the closed interval 0 to 1.5. So you need to remember that the graph is concave up. If the graph is concave up, then the graph of f dash x is increasing. Okay, the next question is question 14. This is a question on applications of derivative. The position of a particle is given by the equation st equal to 3t squared minus 4t plus 1. At t equal to 1, where is the particle? Draw your conclusion on the basis of v1 and a1, that is velocity at 1 and acceleration at 1. Now vt will be derivative of st, that is 6t minus 4. So v at the point 1 is 2. At will be derivative of vt, which is 6. So a at the point 1 is 6. And s at the point 1 will give you 3 minus 4 plus 1, which is 0. So at t equal to 1, since the velocity and acceleration are increasing, the particle is speeding up. The next question will be question 15. This is a rather lengthy question. Two cars have a parking lot at the same time and same speed. They leave a parking lot at the same time and same speed. And car X drives east with a position of xt is 2t plus 3. Car Y drives north with a position of yt equal to t squared plus 2t minus 2. At time t equal to 2, at what rate are the cars moving away from each other? Now x squared plus y squared equal to z squared. So if you differentiate, you get 2x dx by dt plus 2y dy by dt is 2z dz by dt. So you get, now x at the point t equal to 2 is 2 into 2 plus 3, which is 7, and dx by dt will be 2 from here. And y at the point t equal to 2 is, when you substitute t squared plus 2t minus 2, you get 4 plus 4 minus 2, which is 6. dy by dt is 4t plus 2, so dy by dt at t equal to 2 is 6. And z is square root of x squared plus y squared, that is square root of x is 2t plus 3 the whole squared plus y is t squared plus 2t minus 2 the whole squared. And when you simplify at t equal to 2, you get it at root 8.5. So from equation 1, x dx by dt plus y dy by dt, when you substitute, you get 7 into 2 plus 6 into 6 equal to z at the point t equal to 2 is root 85 dz by dt. So dz by dt will be 5.423 because they sort of move in a circle, east and north. Okay, let's move to the next question. Apcalculus question 16. This is on integration. Use a right Riemann sum with 3 equal subintervals to evaluate integral 1 to 4 2x squared minus 3x plus 7 dx. So the intervals will be 1 to 2, 2 to 3, 3 to 4. So right Riemann sum will be f of 2 into 1 plus f of 3 into 1 plus f of 4 into 1, where fx is 2x squared minus 3x plus 7. So f of 2 becomes 1 and f of 3, when you substitute, you get 16. F of 3 becomes 27. So substituting here, you get 1 plus 16 plus 27, which is 52. Let's move to one more question. This is on definite integrals. This is a graph of fx equal to log x, and this is the graph of gx equal to 2 by e squared minus 1 into x minus 1. They intersect at e squared 2 and find the area between the two graphs. So area is left limit to right limit, that is integral x equal to 1 to e squared, top curve, which is log x, minus bottom curve is 2 by e squared minus 1 into x minus 1. Using the graphing calculator, you get it as 2. The next question is, find the volume of the solid produced when this area is rotated around the x-axis. So volume will be pi integral 1 to e squared fx squared minus gx squared dx. That is pi integral 1 to e squared log x the whole squared minus 2 by e squared minus 1 into x minus 1 the whole squared dx. Again, using graphing calculator, you get it as 13.381. So we have learned a few problems on AP calculus, and this will be continued. Thank you.